Okay, lecture 3.2, Universal Asynchronous Receivers Transmitters, or UARTs. These are hardware devices that allow microcontroller CPUs to asynchronously serially communicate with other devices of the microcontroller or peripheral devices. So that's specifically what we're using them for. They're actually used more broadly, but in embedded computing, that's what UARTs are for. Often, the data input to a transmitting UART arrives in parallel, but must be transmitted in serial, right? Because it's a serial communication device. This is achieved via a shift register operating in parallel in, serial out, or PISO mode. Consider the byte 11010001 into a 4-bit shift register. Okay, table 3.1 shows the register contents at each step of transmission. So we take the first nibble, 4 bits, right? A nibble, and it gets put into the 4 bits of the shift register. And so we got 0001, 0001, and that's the loading in step. The next step, we push things, we shift things, it's the shift idea, shift things to the right. So we push the 1 out the right side, that becomes the output. So at a given time, here's the, this is going to happen in a sequence of events. So the first one comes out, it's a 1. We then load in this one into the left register, the shift register. And then we go to the next step, we shift things again. So the 0 goes out in the next step. And we shift everything to the right. So this 1 went to there. This 0 goes in the left side of the register. And this 0 goes there. This 0 goes there. Etc. Right? The next one to come in as a 1. The next one to go out as a 0. All the way down. We see that we make it through the feed here after we've gone through 8 steps. So 1, 2, 3, 4, 5, 6, 7, 8. And we've transmitted our signal. So, but it came out one at a time, right? That's kind of the key idea here, is that they go in multiple at a time, but they go out one at a time, which is the serial bit. So in the corresponding receiver UART, the opposite process, called serial in, parallel out, is also performed with the shift register in SIPO mode. So in this case, you go the opposite way, where you have one come in, another one come in, another one come in, another one come in, and that's the what gets read is the full 4 or 8 or whatever your shift register size is. Great. A UART can transmit and receive data with different rates, parity bits, stop bits, etc., and therefore must be properly configured. So unlike some of these standardized things where like you always have a certain rate at which you're sending data, a UART can change that. It's programmatically changeable, which is nice because it allows you to communicate with lots of different things. So you can communicate with something that's got a bit rate of 9200 or whatever, and you can change it. You can change your UART transmitter or receiver accordingly. And we'll actually have to do that with our UART. So we have we'll be using the UART to transmit data to our LCD display. And so our LCD display expects a certain UART setup. So we'll have to do that. If peripheral devices require a certain serial communication configuration, the UART transmitter controlled by a microcontroller CPU must match the configuration. So for us, the Myrio microcontroller has a configurable UART interface that will be used in lab exercise 3 to transmit data to the LCD display, and I'll give you guys the proper rates and everything for configuring it to set it up. So that when you see it, it's not just like falling from the sky. You know what a UART is, you know why we have to tell it what the baud rate is, etc. So that was kind of the motivation there. Okay, any questions on that? Yeah?
That information would usually come from the manufacturer?
Yeah, so if you have a microcontroller that you're using, they'll have the UART information on there. So the UART is usually an integrated circuit that's very close to your processor on the board, and it will tell you how to do the UART configuration in the manual of whatever microcontroller you're using. The MyRio has certain configuration parameters that it's given. Now that's just for setting up. So it has a function that will allow us to write and read from the UART. The actual rates that we give it are those rates that our peripheral device, so our LCD display, require. So how to use the UART, you got to go to the manual for your microcontroller, how to set up the UART and how to configure it to work with your peripheral device. You have to go to the manual of whatever that peripheral device is. So in this case, the LCD. We have like a parallax, some number in the thousands LCD display, and you look up the spec sheet for it, and it says your UART communication needs to have this baud rate and parity and etc. So, yeah.